Here's a review of quiz 2. And in problem number 1, it's a study concerning whether the daily use of e-cigarettes would lead to an increased risk of heart attack. And in part A, you were asked to identify the sample and the population. So we were told that this was based on 2 national surveys. So the sample would have been those who responded to these surveys. And even though the population is not explicitly given, because these were national surveys, we can infer that the population is all Americans. For part B, the explanatory variable would be whether the person uses e-cigarettes daily. See, that would be one of the questions on this survey. And it's the explanatory variable. That's categorical because the answer is yes or no. And then next, what would be the response variable? Now, this could be a little confusing for a beginner because you might be tempted to say, oh, it's the risk of heart attack. But no, they can't, for each individual person, give a number for that person's risk. All they can do for each individual person is ask, have you had a heart attack? So again, that's yes or no. That's a categorical variable. Now in part D, why is this an observational study and not an experiment? It's because the researchers didn't randomly assign the respondents to groups and tell one group to use e-cigarettes daily and the other one not to. That would not be feasible or ethical. So all they could do was observe who used e-cigarettes daily and who did not. So by its nature, it's an observational study. Okay, in part E, if based on the survey, the ones who responded, 13% used e-cigarettes daily. Can we infer that 13% of the whole population uses e-cigarettes daily? And the answer to that is yes, because what we're doing here is generalizing from a sample to a population, and we can do that as long as the sampling method was unbiased. And if you go back up and reread that, it says that these survey respondents were randomly selected. See, that's the gold standard for a statistician. If the sample was random, then there is no sampling bias. And then we could feel confident in generalizing our sample results to the whole population. But then in part F, it says, why can't we, or can we conclude that using e-cigarettes daily increases heart attack risk? And strictly speaking, we can't, because that would be a causal conclusion. And we've learned that you can't draw a causal conclusion from an observational study. So the answer to that would be no. Now, in problem number 2, it says, show how to design an experiment to answer the question, does ingesting caffeine help mice learn their way through a maze faster? And you have 20 mice. So you start with your 20 mice, you randomly divide them into 2 groups. One of the groups will get caffeine in some form. I don't know if it's caffeine pellets or an injection or whatever, but they will get caffeine. And the other group will not get any caffeine. That other group will be called the control group. Now, usually we don't have to worry about blinding with an experiment that's on mice rather than humans. But there are cases where we have to be a little bit careful. You see, in this experiment, half the mice will be getting caffeine, like I said, in some form. They might need to be taken out of their cages by somebody and given a pellet, a caffeine pellet, or maybe an injection, I don't know. But they might be handled in some way. And the other group of mice should get the same treatment, except that they won't actually get caffeine. Because just the act of taking the mouse out of its cage and holding it, you might, be tempted to pet the mouse, who knows, but that could have an effect on the mouse. So we want to have it such that both groups of mice get identical treatment. If one group of mice are being taken out of their cages to administer the caffeine, then the other group should also be taken out of their cages and whatever, held and stroked or whatever we were doing to the first group of mice. Because, actually there was a study done one time where it involved rabbits, and the treatment group of rabbits were taken out of their cages. And I don't know if they had an injection or whatever, but they're rabbits and people like to pet their rabbits, give them some love, put them back in their cages. And they didn't do that for the control group. Well, that compromised experiment because people didn't know whether the improvement in the treatment group was because those rabbits got extra love or whether it was because of something that they were given. So that's the case here. We want to treat both mouse groups equally in every way, except the one group gets caffeine, the other one gets maybe a placebo. Okay, well then finally, we would then record for each mouse in each group how long it took them to learn their way through the maze. And we would find the average time for the mice in the caffeine group, and we would find the average time for the mice in the control group, and then compare them to see if there's any significant difference. That's how we would do that study with randomization and blinding.